Hello everybody, this is Frédéric Wang from Igalia, and together with my colleague Javier Fernandez, I'm going to talk a bit about the collaboration we have with IPFS. And in particular, we are going to open a discussion about how we can integrate new protocol handlers into Chrome. But before doing that, I just want to do a quick disclaimer, because Javier and I are actually expert in the rendering code of Chromium, while this work really involves knowledge in networking, security, extension, and so on. So yeah, we are really willing to hear advice from experts in these fields, and we hope you can contribute during the open discussion. So this project is, as I said, a collaboration between IPFS and Igalia, and the long-term goal is to implement into browsers direct support for IPFS protocols, which is a distributed web protocol. And for now, we have a less ambitious goal, which is just to allow browsers to access content from IPFS networks through a HTTP gateway. In any case, all this work is really beneficial to the whole web platform community, which is great. So let's start a bit with protocol handlers. So the idea is quite simple. Imagine you have a scheme that is not natively supported, for example, IPFS. So the idea is that you register a page handler for that scheme, and each time a URL using that scheme is loaded, the browser will be redirected to the registered page handler, which is the standard HTTP URL. This actually already exists for the HTML specification. So you have this navigator.register protocol handler API, which takes as a first argument scheme, and as a second argument the URL template for the page handler. However, this has a few limitations that can be problematic for our use case. The first thing is that the allowed scheme are actually quite limited. They must start with either the web plus prefix, or they must belong to a limited HTML safe list. Although the page handler must be same origin with the registering page, you have to ask user confirmation before being able to register the protocol. And finally, because we are going through this redirection approach, it's possible that we have some new bug arising because we are not directly loading the URL. In particular, we found some bug with web services that we had to fix. So in order to work around all these issues, we decided to focus on web extensions, which in theory have more capabilities than standard pages. The first thing we did was to talk to the YANA people, to the Wattwing, to the browser vendors, and so on, in order to extend the HTML safe list. Apparently, that was something that was requested by many people. But at the end, we were not able to reach a consensus between browser vendors. So after talking with the API owners, with the code owner, we decided to just go ahead and ship these new schemes for distributed protocols. But yeah, that's a bit unfortunate because it is not in other specification or in other browsers. But we were not able to reach a consensus. The alternative approach would have been to only allow this for web extension, but that was discarded by code owners. Then the idea is to relax these security rules, but only for web extensions, because we consider that extensions are more trusted resources than arbitrary third-party page. And thanks to that, we can now install a web extension that open a page and register a protocol handler globally. And this only requires to ask user confirmation once. But if you really want the details, the UI is that you basically first install the web extension, then you click the logo of the extension to open an extension page, Then from this page, you can click a button to register the protocol handler. The protocol handler will first open a pop-up asking user confirmation, and then you have your protocol registered. And as you can see, this is a bit cumbersome, and this is why we would like to move to a different approach. The alternative would have been to just follow what is done in Firefox or for progressive web apps, which is just to extend the web extension manifest in order to allow registration at installation time. Unfortunately, that was discarded by code owners because they preferred really to do the security check and the user request at installation time. And finally, I mentioned that there are some related tasks that are still useful for the web community. So let's mention a couple of them. First, each time you have a new API for the web, you really only want it to be restricted to what is called secure context, because the API is maybe too powerful. So yeah, the only problem is that this secure context is defined in the specification, but not really implemented consistently between browsers. And even within Chrome, there are something like 6 definitions and some duplicated code. You have some things that were not aligned with the specification and so on. So we really had to clean this up and trying to unify the code, and now we are in a much better state. And then I already mentioned that we had to fix some bugs between service worker and custom handlers. And finally, we also improved the parsing and validation of the protocol handlers URLs. But as I said, this web extension approach is not ideal, and so we decided to move to a different approach that Javier is going to talk about now.
Thanks, Fred. In this second part of the talk, I'm going to describe a new approach to register protocol handlers and the code refactoring that this feature needs to be implemented. Why we need to do this change? The main reason is avoid the need of installed third-party software to register protocol handlers. This is the case of the web extensions approach, already described by my colleague Fred, and also the progressive web applications as custom handler, which was shipped recently by Microsoft. We want also to simplify the user authorization, which will happen just once and at runtime, the first time the handler is used. And finally, we want to facilitate the addition of new schemes that probably or be just useful for specific use cases of the embedders or even Chrome. It should be relatively easy to implement this, since the Chrome OS already use these predefined handlers for the mail-to and webcall protocols. And obviously, we still need to implement the same or similar security and privacy checks that the ones used by the web extensions through the HTML API. And we want to expose this feature via runtime flags, so the user just need to switch on the flag to opt into this feature. As I said, we need to apply an important code refactoring in the protocol handlers logic. The goal is to move as much code as possible to the content layers, so that we allow embedders to reuse this Chrome protocol handler logic and implement their own predefined custom handlers. We want the content shell to be able to run the protocol handler logic so that we can improve the web platform test coverage. And finally, we want to produce a more robust and consistent security logic, avoiding the code duplication that we already detected in several parts of the Chromium codebase. And the current design, the protocol handler logic lives in the Chrome layer, but we think that this logic is generic and useful enough to live in a more accessible layer. However, there are important dependencies that need to be analyzed carefully. Perhaps the most challenging one are the permission and keyed services interface dependencies, but there are several others. The first approach, moving all this to a new content public API, has several challenges. The main one is that I couldn't find any way to solve the dependency with the keyed services from the content layer. So during the review process, some engineers suggested to create a new custom handlers component. Moving this logic to the component layer will definitely solve all the dependencies with other components. However, as I said, we want the content shell to use this protocol handlers logic. It would imply that it will depend on the content layer as well. This refactoring would imply or would require that we still have some specialized delegate in the Chrome layer to deal with the underlying operating system APIs. And the factories, each embedder and Chrome will have their own factory to create the appropriate delegate instance and the registry. This design and the implementation, the prototype we are working on, we still have some open issues that I will describe now, and hopefully we can discuss them later. The main one is the decision about going with the content public API or a new component. It's debatable if the protocol handler logic needs to be it needs a new content public API. The design document describes some requirements that the feature has to pass through the whole development life cycle and has an associated spec and be tracked by the Chrome status dashboard. And I'm not sure this match what we want here, what we are doing here. But having a public content API would allow us to implement most of the logic in the content client and content browser client interfaces, and only the specialized logic will live in the embedders and Chrome layers. On the other side, the component approach will definitely solve all the dependencies with the keyed services especially. But there are some suggestions in the reviews that perhaps hanging it off the storage partition would allow these per profile requirements, per browser context requirements that the keyed service has. And finally, this approach has the problem, as I say, that the content shell would depend on component. We want to ensure that this is valid or something that we want. One of the goals of this refactoring is to allow embedders to implement their own predefined handlers. So we need an extensible design to do this. Perhaps the registry factories that will create the appropriate delegates can also provide implementations for these predefined handlers. Another issue with these predefined handlers is how we will implement the security and privacy checks. The approach, the web extensions do that registration time, while the user intention of installing the progressive web application may imply a kind of level of trust. We need a way to do this for these predefined handlers. And finally, we need embedders and content shell to use the protocol handler throttle that now is implemented in the Chrome content browser client class. There is a to-do, as a matter of fact, to move this class to an independent file and become an independent class as well. So this new design and refactoring would allow us to define a common protocol handler throttle logic that will be used by the content shell and embedders and Chrome. And as I said, perhaps this could be a good place to implement this user authorization and for these predefined custom handlers. And here you are some reference if you are interested in some details of the design and the discussions we have with several engineers. And that's all. Thank you very much. I hope we have a nice discussion now about the open issues I described. Thank you.
Hi, I'm happy to answer any question by here or reading them in the chat.
So can you hear me, Javi?
Yeah.
So Javi, can you hear me?
Yeah, I can hear you.
Okay, I think there are some questions in the chat. Tom Jones is asking whether there is any limit to the types of protocol that are acceptable. Do you want to reply to this one?
Well, I haven't thought about that.
So I guess there are two different things that we didn't really mention, but I think actually the register protocol thing is registering a scheme, so not really implementing the whole protocol.
Yeah.
So for this part, I guess the limit is only the safe list that is in HTML.
Safe list. Yeah.
Then for the complete protocol, it depends on the protocol, I guess. I guess, for example, for IPFS, I think some people from IPFS can reply better, but there are some discussion about trying to implement this with JavaScript. Or I don't know. Actually, I guess it depends on the protocol. So Tom John is mentioning a protocol that connects a user wallet to a relying party. I'm not sure I understand this comment.
Hi, Beatrice.
I think I can maybe provide some information. I think there's two parts of that question. What is an acceptable protocol is first what can be implemented within the structure of Chromium and the infrastructure, like for example, the whitelist and that, and how far we push on what is possible there that is not HTTP or doesn't conform well to how HTTP or the pipeline, the network pipeline works. The second part of that, I think, is an ongoing question that's happening at the W3C right now, which are questions about non-HTTP protocols. And Tom Jones mentioned well, it's and this is things like IPFS, which are paradigmatically different from HTTP, both in terms of the security model, the trust model, and the network stack implementation itself. So I think there are many dimensions to that question. It's very difficult to answer. One of our goals, I feel like, in our interest in this project in particular, is to enable people that build on Chromium to experiment with these different alternate protocols. Brave is already shipping IPFS, but it's kind of bolted on into the side, and it uses a full IPFS implementation with IPC in between, HTTP IPC actually. And then we're very interested in, and we have other user agents and companies that are interested in more native implementations. Do you do that natively in Chromium? Do you do that through extension? do that through PWAs. Perhaps there's a JavaScript way of doing it. It's yet to be, it's not clear yet. But I think the work that this particular project does is it enables the ability to do those product experimentations in a way that Chromium doesn't allow at this point.
Yeah, so I don't know if that answers your question, Tom.
Sort of, I guess. So first of all, whether or not you have a completely different protocol or not, I mean, I guess most media have different protocols in TCP. So that's already the case. And we've used SIP before to enable voice. So we have this idea that there is another protocol mostly established around the connection phase of any interchange, like SIP is. So is SIP one of those things which is supported, or is it assumed that that somehow happens out of band of all of this? SIP is the session initiation protocol, by the way, that's used in voicemail or in all voice connections.
Yeah, Javi and Fred, you might have a better answer to this, because I think to some extent, I think Tom's point is really interesting. There's all kinds of non-HTTP protocols in the browser, but often they're not content. They go down an entirely different pathway, like WebRTC. They have different permissions models than opening an HTML page, for example. The use cases are really different, and the models around how users interact with that content is very different than opening a top level navigation might be a good way of just describing the difference in how those are handled.
Yeah, well, so far we are just prototyping a way to make embedders of Chromium to define different handlers, but the use cases are still to be figured out. I think each browser that embeds Chromium has its own use cases, and we'll have the ability with this refactoring to implement handlers for those protocols. But I still fail to see which protocols will be the ones more with more chance to be reach the users in the end.
Is this on a, has this advanced to the point where it's a trial yet, or what's your status?
Well, we are still refactoring in a very early stage. Most of the protocol handler logic was in Chrome layer, so very specific to the Chrome browser. Other browsers had to fork everything and patch the Chrome layer. And we think that the first step was to move this to the content layer, or maybe a component that would be more accessible to embedders. And once this is more stable, we will see how to ship this, probably in a trial, as you said. But so far, we need to stabilize the component, which seems the most promising approach, more than the content API. But let's see. And once this is more stable, we will talk to embedders and see how they can use this logic.
Yes, actually, one goal of this talk was to start a discussion with code owners so that we can see which design approach they would like. But I'm not sure we have a lot of people. I think Javi invited some people who knows the code better, but I'm not sure they're here.
Yeah, I asked a question about cross-protocol requests. It's kind of like down there in the deep future when we move beyond redirects to HTTP, because like when you redirect to HTTP, you kind of like stay within HTTP. When the security like cross protocols are in between HTTP and HTTPS. those are kind of like well understood. But we may hit a future when we need to answer some questions about if we have like a protocols different than HTTP for loading content, like specifically content, and your root document is in one protocol, and you fetch from a protocol which gives you a different like security guarantees and constraints. We don't have a good understanding of even like open questions that may arise. So it would be useful to have other like protocols which are focused on content. I'm mostly interested on IPFS, but like maybe like page loaded, document loaded from IPFS, fetching something through a different document, how that story would look like. If someone has interesting use cases like that, I'm happy to listen as a follow-up, discuss as well.
So if we have these use cases, how do we get them to you?
You can join join our Matrix channel or our IPFS repos. Reach out to us there or to me directly.
You post the links?
Yeah. We also have like a specific repo about IPFS in web browsers when you can like open the issue. I think it's something we should have a discussion. It's down the road, but the sooner we start thinking about those constraints, the better.
Because I think we only have 1 minute left, so maybe we can check other question in the chat. I think Mauve was asking whether this work is going to include to make sure that the protocol works with stuff like service brokers. Yeah, I guess the answer is that we ideally we want the protocols to behave like any other protocol. So, well, Marcin was mentioning this security check, but we also had this issue about service broker, and I think I mentioned this, that we had to fix. Well, we found some bugs with service brokers that were not working with this register protocol thing, and we had to fix them. I think then Marcin, you were asking some question, but that's already done. Some move question, I guess it's the same thing. So Tom was asking a mailing list for this effort. I'm not sure if this question was related to what Marcin was talking about or about the Chromium development. But we don't really have a specific mailing list. I think, Javi, you were writing to the network. I think it was network Chromium group or something.
Sorry, could you repeat the question, please?
If we have a mailing list for this effort.
Oh yeah, well, we started the discussion about the refactoring and our plans to support other protocols like IPFS in the net dev mailing list, the BlinkNet. Sorry, Blink. And well, we also asked in the embedders dev mailing list as well to gather opinions from embedders about the refactoring and how they if they can contribute to the design doc. So if you want to add more feedback there or even write suggestion in the design doc, it's open.
So Dietrich was also, I think it's the same thing, is about a Chromium issue to follow this work.
I think there is one to move the protocol handler to the content API, to the content layer. I think there is a Chrome issue, but I don't have it right now.
Yeah, okay. So I guess there are more, I'm not sure there are more discussion in the chat, but that's more or less related to the same idea about that we need to define more about how this new protocol thing is going to interact with security and so on. So
Yeah, that's critical.
that's really open question, and I'm not sure. As we said at the very beginning, we are actually not expert in this, so it would have been better if some people who are more familiar with this code could answer. But yeah, I don't know.
Yeah, as I said in the presentation, one of the goals of this refactoring is also to get a more consistent mechanism of implementing these security and privacy checks, because right now it's kind of distributed across different parts of Chrome. So this refactoring hopefully will help to do that in a more common or generic way, and we will figure out the issues with the predefined protocol handlers during this work.
Okay, so I think we are running out of time, and there is a very interesting session by Brian about the history of the web that's going to happen now. So I guess we must close this. So thank you everybody for participating.
Yeah, thank you very much.
And hopefully we can continue to discuss about this later. Bye.
Bye.